Another example. So this example says, evaluate the following. We have the line integral over curve C of this function, y squared dx plus x dy. Okay, it's a combination of x and y's and dx dy's, and C is the line segment from -5 and -3 to 0 and 2. Okay, line segment. It's a piece of line between -5 and -3 to the terminal point is given to us as 0 and 2. Very good. So here we have two variables and we have one integral. So it means that we have to get rid of one of the variables or introduce a third variable. First of all, recall that the vector representation of line segment starting from at r sub 0 to the terminal r1 is written this way. So the vector is defined as 1 minus t r sub 0 plus t r sub 1, and t is bounded between 0 and 1. And from elementary calculus, we learned about the vector representation of a line segment this way. Very good. So now we're going to use the definition that we learned before and write down this curve into the form that we can actually get rid of x and y. So let's see. R of t is equal to 1 minus t, and here you have the initial point, -5, -3, written in vector format. So as you can see, I'm changing this parenthesis into vector symbol plus t times 0 to 2. So R of t is equal to, here you have -5 plus 5t, comma, -3 plus 3t plus 0 and 2t, which gives me, if I add the first components, I get -5 plus 5t, and if I add the second components, I get -3 plus 5t. This is my x, and this is my y. X of t, and this is my y of t. Now you have something to work with. So this is your integral. You need to use xt, yt, the parametric equations, and substitute them here. So the line integral c y squared dx plus x dy is equal to, here you have t, which is bounded between 0 and 1. We already know that from the recall from elementary calculus. And y squared, let's see, what is our y here? Y is 5t minus 3, 5t minus 3 squared. But what is dx? Dx is the derivative with respect to t, which is 5 dt. So this is our dx. Let me just write it down here so you know what we did. This is dx. And plus, now here I have x dy. My x is 5t minus 5. And here I have dy. dy is going to be 5 dt. So dx and dy. Perfect. Now let us take the integral. This guy is equal to the 0 to 1. And let's take the first integral. And here you have u sub. So you're going to end up with 1 over 5, 5t minus 3 to the third divided by 3, 0 to 1, and you have another 5, so you don't need this 1/5, you already have that. And plus, again, you have this guy here, you get a half, 5t minus 5 to the second, 0 to 1. So if I substitute 1, what do I get? I get 8 over 3 minus, let's see if I plug in 0, negative 27 over 3, which is just 9. So plus 9, plus a half. And here you have, if you plug in 1, you get 0. Minus, if you plug in 0, you get 25. Okay, so let us do the algebra here. A third plus 9 minus 25 over 2. We need to take the common denominator, which is 6. 16. 54 minus 75. Okay. So here we get negative 21 plus 16 divided by 6, which is going to be, let's see if we can see the whole thing, negative 5 over 6. This is your line integral.